Right, this is lecture 4 of chapter 9, and we're picking up with covalent bonds. So this is the other major type of bond. So we saw ionic bonds. Those are the bonds formed between a positive and a negative ion. Here, we're talking about the bond between atoms, where instead of creating ions, what we have are two atoms sharing at least one pair of electrons. We'll see in some cases they're actually going to share multiple pairs of electrons, but they have to share at least one pair of electrons. And they're going to do this to form their octet. So the exception is hydrogen, which is who we're seeing over here. But remember, we've got other atoms. So for example, carbon. Carbon has just 4 electrons in its valence, in its outermost level, and so it needs 4 more electrons to make its octet. And so it's going to make covalent bonds with other elements in order to fill that octet. So atoms in covalent compounds are overall going to be electrically neutral. And there we go. So once they are in those covalent compounds, they will be electrically neutral. We'll see that depending on how they are bonded together, they may actually create a charge on the entire compound, but we'll talk about that a little later. So examples of covalent compounds. Things that are in covalent bonds, sorry, not a covalent compound, diatomic gases, these are molecules that are in covalent bonds. So the one that you're seeing over here, this is hydrogen. So hydrogen, this is the exception for the octet, because remember, this guy only has 1 electron, and it can only fill its outer shell to 2. So it's going to get 2 hydrogens that are going to come together, and they're going to share those 2 electrons and become a covalently bonded molecule. Other diatomic gases that are in covalent bonds are things like oxygen, nitrogen. Those are the major ones that you know. Chlorine will also do a covalent bond. So how do we draw or show covalent bonds? So we're going to use electron dot notation. So that's one way we can actually present a covalent bond rather than drawing these electron clouds that we just saw on the previous slide. So just like we saw when we were looking at ions, so we've got hydrogen with their single electrons, and when we bond them together, we just draw them with their 2 electrons in between. This indicates a covalent bond because they're sharing the electrons rather than having stolen them from each other. Now, when we get into something like chlorine, chlorine, remember, has 7 electrons in its outermost shell, and so it needs to only find 1 electron in order to fill its octet. So here we've got these 2 chlorine atoms that have come together. They're sharing, and they have a bonding pair here in the center. So these are the 2 that they're sharing in the covalent bond. So that's why we call that the bonding pair. The other pairs that are in that outer valence are what we call lone pairs. So they're paired, but they are not going to bond to anything. And so that's why they've been given this name of lone pairs. So that's the difference between what a lone pair is and a bonding pair. So the bonding pair is the pair that we see in between the 2 atoms when we do the electron dot diagram. So let's do some practice. So what would the electron dot diagram look like for water? Well, if we take a look at our periodic table, we know, because we just saw hydrogen, hydrogen has just 1 electron. And if we look at oxygen, oxygen is in group 6A, so that means it has 6 electrons in its outer most valence. So if we draw it, we're going to put oxygen in the middle, and we'll put 2 electrons on the top, 2 electrons on the bottom. Those will be lone pairs. And we're going to put 1 on either side. So there are the 6. We'll put the ones that are bonded to the hydrogens on either side with our hydrogen and a hydrogen. So that is what water would look like as an electron dot diagram. So we've got some others. So here we've got carbon and 4 hydrogens. This is methane. So again, if we take a look at the periodic table, we need to find out, we know hydrogen has 1. What does carbon have? Carbon is in group 4. So that means it has 4 electrons in its outermost shell. So we're going to put in carbon, and it has 1, 2, 3, 4. I showed that to you in another video because some of the dot diagrams show it drawn differently. This is the easiest way to draw it so that when you go to bond it, you can see it this way. So then you've got a hydrogen on each side because each hydrogen has an electron to share. So hydrogen up here and a hydrogen on this side and 1 down here. So that's what the electron dot diagram would look like for methane. So covalent compounds, once you've learned how to draw the diagrams, they are compounds, obviously, held together by covalent bonds. So ionic compounds held together by ionic bonds. Covalent compounds are ones that are held together by covalent bonds. The big difference here is that with ionic compounds, remember, they are generally between a metal and a non-metal, like sodium and chlorine. Covalent compounds are generally going to be formed by non-metallic elements on the right-hand side of the table. So if we take a look, we are going to generally be building our compounds, our covalent compounds, from guys on this side of the table. So most of our covalent compounds you're going to see being built from the elements over here. So how do you figure out what the number of unpaired electrons are? Well, for elements for family 4 through 7, the number of unpaired electrons is 8 minus the family number. So, for example, family 4, you go 8 minus 4, and that's going to give you 4 unpaired electrons. If you're looking at family 7, it's going to be 8 minus 7, so it's going to have 1 unpaired electron. So this is going to tell you how many unpaired electrons you've got. Now you can also just go ahead and draw the diagrams. In fact, most of the time what I do is I actually just above each of these guys draw what the dot diagram would look like for the element in this column. So, you know, draw the 7 dots over top of this, the 6 dots here, the 5, the 4, the 3. That way you've got a kind of a quick and easy way to look at them to find out how many electrons they've got in that outer valence. And let me erase that. The thing is that this number of unpaired electrons is the number of covalent bonds that are possible. So, for example, for carbon, that 8 minus 4 gets us 4 valence electrons, 4 unpaired electrons. That's the total number of covalent bonds that it can make. So it can make 4 covalent bonds. So it's kind of a convenient way to figure out how many bonds these guys can make, because that's the number of unpaired electrons that are there, the number of openings that they need to fill up to make their octet. So the thing is that those 2 dots in between, or any 2 dots on an element, can represent either a lone pair or a bonding pair. We usually actually won't draw them as dot diagrams. We do that so we can kind of practice and get the idea of how this is working. But what we usually end up doing is drawing bonding pairs by drawing them as single lines for each pair of electrons shared. So you can see here what that would look like. So here's our hydrogen. We saw this one before with the dot diagram. So instead of drawing it like this, we draw it like this with the 1 line bond between the 2 elements. You've probably seen these before in chemistry. Same thing for water. So here's the water we saw similar before. I drew it straight across. They drew it at an angle. We'll talk about why that is later. But this is the dot diagram. This is how we'd actually show it. So that way you can see that there are the 2 bonds that are bonded to the oxygen, and that way we can ignore the unbonded or lone pairs of electrons that are in this molecule, because we're really only interested in knowing about the bonds that are in the covalent bonds between the atoms. So this also helps when it gets to when we are looking at multiple covalent bonds, because any element that has more than 2 available spaces to make bonds can make multiple covalent bonds. So obviously, if you have 2 atoms sharing 2 pairs of electrons, we're going to call that a double bond. So they can have single bonds like we've seen with water and hydrogen, or they can share 2 pairs of electrons and create a double bond, which makes a stronger bond between those 2 atoms. These are common in compounds for carbon, nitrogen, oxygen, sulfur, because all of these atoms have the ability to make 2 or more bonds between other atoms. An example of this would be ethylene, which is a common thing that you find in things like plastics. And we represent a double bond by a double line. So as you can see here, this is what the electron dot diagram would look like. So we've got our 2 carbons. The 2 carbons are sharing 2 sets of electrons, and then the carbons are sharing electrons with each of the carbons, or sorry, with each of the hydrogens. Or instead of having all these crazy electron dots, instead we can just show there are 2 bonds between the carbons and then a single bond with each of the hydrogens. And this shows us that there are 4 bonds with the carbon, 4 bonds on this carbon, and then a single bond for each of the hydrogens, which fills up each of their outermost valences. Actually, I'm going to stop there, and I will pick up more with the multiple covalent bonds in our next video.